internet! As you can see from the intro of this video, we are doing Beyblades. And behind all of that metal, you can see that there are a ton of physics at work. And one of them are energies. Or, to be more specific, kinetic and potential energies. So if you've come looking for that, you've come to the right place. But we'll talk about that later, because we need to know about background knowledge. What you need to know is that there's physics laws. These are kind of like the rules of the universe, and they help to kind of describe what something can or cannot do. For example, gravity and how mass is attracted to each other. The laws of conservation of energy. And finally, we have the second law of thermodynamics. Ooh, scary. Well, it's just not that scary if you take into consideration how confusingly they word it. So let's begin with the law of conservation of energy, since that's a good place to start. So I'm sure you've already read what's on screen, but what does this mean? It means that energy in something will remain the same if it's not being disrupted by anything else. So to understand this better, we need to know what energy actually is. And it's the ability to do something or change something. So this is more clear to understand, but what isn't clear is how is it lost? Well, that's best explained through an example. For example, let's say we have a bouncing ball and it comes down. So when it comes down, not only does it start to convert all of that energy into motion energy, something we're going to talk about later, but it also loses some of that through heat. And just as a side note, both of these were oversimplified examples, and I do recommend you rewatch the video a second time. Things will get clear then. So we need to know about two energies, kinetic and potential energy. Kinetic is actually quite simple, and that's the movement of particles. It'll make more sense of what kinds of movement later once you see everything else that's inside of it. Potential energy is energy that is kind of like stored up. For example, if you just have a floating ball, once you start letting physics do its magic, then you'll notice it'll suddenly go down because of gravity. This is potential energy because it's stored up. Another definition is it's the energy stored in its location. So remember that, as it will be very useful in the future. And both of these make sense once you take into account gravity, for example, or if you take into account nuclear energy. So as you can see, there's this list here. So we'll begin with chemical energy. And chemical energy is energy stored inside of atoms and molecules. And you can see this a lot. For example, burning wood. Inside of all of those wood molecules, you can see that there's energy stored up. As soon as you burn it, a chemical reaction happens and it releases all of that energy. So it changes that potential chemical energy into kinetic thermal energy. Next, which follows suit, is mechanical, which is really quite simple. It's kind of like compressing a spring or stretching a rubber band. It's the build-up of tension in objects. Being the most complex out of all of them, nuclear comes next. And it's pretty complex, so the best way to know about it is that it's the energy inside of atoms that's given off whenever you do a process, for example, fission or fusion, or in other words, gravitational. It is pretty easy. Remember that ball example? It had so much potential energy, and guess which form it was in? That's right, gravitational. So this is kind of like an intermission for us to reflect on potential energy. We know that based on where it is or based on what kind of state it's in, it'll have that energy. And now I'm here to debunk one big lie. Now, there is a myth that if there's like a ball, let's just say it's over here, and now it's about to fall. So when it comes down, what you may see is that it comes and that it starts bouncing and bouncing until it slowly stops and runs out of energy. So what this looks like is just you destroyed energy, but this is not actually true. You have to be more careful about that. And that's because the law of conservation of energy. Energy cannot be created nor destroyed. And the reason that happened is because of the second rule of thermodynamics. All energy transfers aren't 100% efficient, and because of that, it started losing energy. Because all of that energy was now dissipating into the atmosphere from all of those conversions. And there are no exceptions to this. Most of the time, it's going to dissipate as heat, but it could be other things. For example, sound, or when you purposely make something that's supposed to transfer into heat, like a heater. And kicking off kinetic, we have radiant, which you already know, but it just goes by a different name. Radiation. So this means gamma rays, X-rays, ultraviolet, radio, microwaves, and visible light. Thermal, we have talked about this a lot during the video. And thermal energy is also known as heat. But we need to know what heat is. And heat is just the vibration of molecules. So the faster they vibrate, the hotter it is. Pretty simple. Motion energy is kind of like the definition of kinetic and is very similar to thermal, and it means molecules moving. But how it's different to thermal is that thermal stays more in place and it vibrates more. But motion energy, it vibrates less, but it moves more. Sound. You already probably know what this is, but if you don't know, sound is just the waves of molecules vibrating. Sound waves travel in kind of like the same way as throwing a rock into a pond. It moves in circles, expanding outwards until it dissipates. And finally, electrical energy, or electricity, which are tiny particles called electrons. And we're done. Nope! Just kidding. We're actually done. All the background knowledge. And now we can see this, how it relates to Beyblade. So I'm going to take two scenarios here. One which two Beyblades are making contact, and one which a Beyblade is just spinning by itself. So let's begin with the singular Beyblade. When it spins, it loses energy throughout the entire Beyblade. So it loses it through sound and thermal energy. The sound energy you can hear from the Beyblade, and the thermal energy because the vibration of molecules from the Beyblade is vibrating the molecules in the air. Then, when the Beyblade is starting to run out of energy, you can notice that the gravitational energy starts to overpower all the other ones, and so it falls down and sometimes rolls. Now, when they collide, they convert huge amounts of motion energy into other forms like thermal or sound energy. Now, let's take one of my most favorite Beyblades, Fafnir. Whenever Fafnir comes in contact with another Beyblade, they both share their energy, so it's the same. So, if Fafnir has less energy than the other Beyblade, then what will happen is that the motion energy of the two will equal out. That is all. I hope you enjoyed. Remember to do like and subscribe, and see you next time.